Hello, in this video I would like to give you an ISS imaging tutorial to show you how I can make this kind of footages. It's not a CGI, it's not a hologram, it is actually made from an original real footage. But to show you how it works, I need to show you this example first. This was basically so in my free time I photograph aircrafts as well, and I use a Dobsonian scope, which is a manual scope. It's a very simple built telescope. You can just move it up and down, left and right. So I was tracking this amazingly weird looking aircraft called the Boeing Dream Lifter, which carries smaller parts, but anyway, I don't want to get too much into details. You can do your research if you are interested. So it was flying just right over London, and I was tracking it manually. As you can see, it's pretty shaky, it goes all over the place. I edited it, so usually I used the blue sky footages. So you need a software called PIPP. It's a free software, anyone can download it, and look what it can do to a footage so shaky, what you just saw seconds ago. It does a simple trick. There's a detection option, and then you can just choose certain objects. It can detect automatically, or you can actually specify pixels, the amount of pixels you want it to identify, and then as it detects on every frame, it basically goes through every frame and it moves to the center. So on the same basis, I show you now just a short part of the original footage I recorded about the ISS basically last night, and it just goes all over the screen, because I'm tracking it manually, and it's a pretty hard job, I can guarantee you. So I will show you now how I usually use this very simple software to basically get rid of all the shakes. So once again, let's see the original one, the original footage. I know that the ISS was quite visible around 1 minute 44 and basically onwards. Yeah, it goes everywhere, but that's absolutely normal. And then I just grab and I drag and basically drop into PIPP, and once it's done, make sure that you click on the ISS option, because then it will crop it around and it will just act the way it should be. Then choose TIFF, because you want frames at the end of the day, at the end of the process. So once it's done, it's really not rocket science. Now it's just keep going on, you just let it basically process. I stopped the recording for a second. I sped up because I wanted to show you the end result, but I realized that you can just take a look in the folder during the recording as well. So here we are. You can see it's still producing the frames, but it doesn't matter. I can show you what I really wanted to show you. So if I move it up and if I open any frames, then you can see the individual frames from the video centered properly as it should be, and I just need to go through and see exactly what I've got. You can see that on some footages, on some frames, it's like a chewing gum. It's elongated, it's distorted, it has all kind of problems. It's basically the result of the fact that I'm moving the tube, moving the scope, and it's not always there the way it should be. So basically I'm following it on its path, and when it's really nice and crisp clear, it means that I just managed to move the scope with the same speed as it was moving along the sky. So to get the right results and not being weird, you need to delete all the frames which are which are distorted, because otherwise it would just look pretty fake. If I have to admit, if I wouldn't do this, probably I would question the same questions, and I would say the same thing, that oh, hold on for a second, something is not really okay with this. So you see, once I deleted all the distorted frames, I can just speed it up basically just in the picture viewer in Windows, and you can see it's nearly now like the end result. And this is the reason why it was turning so quickly is because I missed a little gap. It was hazy, it was cloudy a little bit, but thin clouds, and that's why you can see that the brightness of the ISS is dropping sometimes. It happens, yeah. So once I go through the frames, because eventually I want to find the best possible frame, I just chose now one, and I open up in Photoshop, and then I go to just simple settings, saturation, contrast. So I just go to filters and camera roll option, and then you just play a little bit, basically just to find the right settings, basically to see more details. Luckily I was happy with the end result, and yeah, just a little play, highlights and shadow, probably. I always do it by feeling, probably a little bit of luminance, a little bit of sharpness, and but this is just a very quick one, just to show you exactly how I get to the final, basically the final results, how I get those, and just the journey. And if I zoom in, I'd like to show you. So that's the beam, the Bigelow expandable habitat. That should be the Soyuz MS-05, just docked there. That's the Leonardo segment or module. That's Kibo, the Japanese segment. Just right next to it, that's Columbus, European Space Agency's module. That should be the other Soyuz docked, and that's Progress 67, which is nicely visible. But how do I know about this? Well, on NASA's website there is always an animated picture about the current situation on the International Space Station. So you can see the Soyuz right next to beam. There is the other Soyuz MS-04, which will be the vehicle for Jack, Peggy and Yuri to come back to Earth. And then you can see Progress 67 at the end of Zvezda module, and that's why I'm happy for, because it's on my photograph. So once again, this is my final photo. You can see beam, the Bigelow module, you can see Soyuz MS-05, which just arrived last Friday, and Progress 67. This is the scope I used. This is the 10-inch 250-1200 flex tube ozone scope. I used a focal length of 3 meters with the Teleview extender. I hope I managed to clarify a few details, and if you like it, subscribe please.